Hello students, you are once again welcome to Dr. OJ's tutorial class. In this video, we shall be looking at type of functions and their graphs. So let's start with the constant function. The constant function. The constant function. When is a function said to be constant? Now, the constant function has the form, f of x is equals to k, where k is a constant. Now, the graph of a constant function is always parallel to the x-axis. Always parallel to the x-axis. Let me give you a sketch of how it looks like. This is it. Now, if it's a constant function, so let me use the black ink here. Yes. So let's call this one k, and we have this as our x-axis, we have this as our y-axis. So this is its origin. So this is the graph. So this one is f of x is equals to k. What it means is that irrespective of the value of x, the y remain constant. I can say this graph touches the y-axis here. This is the y-axis, it touches it here. So y remains constant throughout. You can see it goes horizontally like that, parallel to x-axis. So if the value of x changes, the value of y will not change. It will remain unchanged throughout. So now the range and the domain of that graph is, for this graph now, the domain is set of real numbers. You can see that is every possible value of x will fit in here. Why the range? That's the domain, that's the range now will be k. Why? Why do we call the range k? You can see that it has only one value of y. So and we have been taught that the range of a graph is a set of what? Is a set of output values, a set of y values, the output. So the elements you have in the codomain, the mapped one from the domain forms your range. Sometimes all the elements there might be mapped, like I've taught you in the previous videos. So the range of this function is k. K is the only value of y. Y, the domain of the function is R. That is, so many large values of x are in the graph as the domain. Okay, don't forget, domain is a set of x values, input values. So let's go to the next one. Next one is what? The linear function. Now, what is the form of a linear function? It has the form that is, it looks like f of x is equal to ax plus b, where a and b are constants. A and b are constant. The graph of linear functions are always what? Are always straight. Its graph is always a straight line. It's always a straight line. So let me sketch it. Suppose we have something like this. Okay. Now let's assume we have this. I've drawn two different graphs here now. This first one, I see that it goes up. You can call it f of x is equal to ax plus b. Here, our a, the coefficient of x here will be positive. That's why a is greater than 0. But for this one that goes down, f of x is equal to ax plus b. But here, our a is negative. Okay, so those are the equation of the graphs we have on this y and x axis. Okay, now we can have a very good example here. Suppose we have a graph Let's say we have a graph f of x is equals to 2x plus 3. Suppose we are asked to sketch this kind of graph. How do we go about it? Let's do that in the next frame. How do we go about this? It's not difficult, it's very simple. F of x is equal to 2x plus 3. Suppose we are asked to sketch it. Obviously, f of x is equal to 2x plus 3. If you look at it, if you compare it with the equation of the graph we just done now, f of x equals to ax plus b. You obviously see that both of them are straight line. They are linear graphs. A here is 2, b will be 3. Okay, so now you can easily plot this. What you just need to do here to get the point at which the graph will now touch the x-axis there is let 2x plus 3 equals to 0. So by the time you evaluate, collect like terms, 2x will be equals to minus 3 because this one goes here and becomes minus. So x equals to minus 3 over 2. So that means that this particular graph, is going to have x-intercepts on, that is at minus 3 over 2. So that is the negative side of x. So this is 0, x is positive here, x is negative here, So minus 3 all over 2 is where the graph will touch the x-axis. And obviously, if that happens and it's a straight line graph, it means that the graph is what? See. Can you see? So it's what? It's a positive graph. So f of x is equals to 2x plus 3. And obviously, since our a, which is 2, is not negative, it's more than 0, it's positive. So this is how the graph will look like. If our a had been negative now, obviously this point is not what we're going to get here. It might be something there. Maybe minus 3 over 2 will now become 3 over 2, and it will now go down like this. But because our a is positive, it's going to be a positive sloped graph. Positive slope graph. So that is that about that. Please don't forget to click on the notification button so that each time I produce new videos, you'll be notified. So thank you. God bless you. While we look on to seeing the second video, still on types of functions and their graphs.